Good morning, everyone. My poster number is 36. I am presenting the presentation. The title of my presentation is Development and Evaluation of Ionic Liquid Based Transdermal Patch for Systemic Delivery of Repaglinite. Okay, so moving forward, the main aim of this presentation is development and evaluation of Ionic Liquid Based Transdermal Patch for Systemic Delivery of Repaglinite. The repaglinite is a short-acting of drug for type 2 diabetes which increase the insulin release. Take before a meal to control the blood sugar. Then the objectives are formulate and characterize of ionic liquid based transdermal patch of repaglinite. Then improve a solubility, skin permeability and systemic bioavailability. The introduction, the diabetes mellitus of chronic metabolic disorder which impair insulin secretion or action. Diabetes mellitus is a chronic disease which increase insulin does not work to properly, causing a high blood sugar. So it can be lead to a complication in eyes, nerve, kidney and heart. In this, type 2 diabetes is a very common and often diagnosed late. In this, the repaglinite is a oral, short-acting and a drug to help a pancreas release insulin into control the blood sugar. The next, moving forward, the methods. In this, we first synthesize a chlorinic olate and prepare a repaglinite in a ionic liquid form. Then after confirming that the preparation, after confirming its property, we make a patch and then optimize its using by the box Benton design. And then finally, we evaluate the patch. Then the moving forward, the result and discussion. In this next part, the result and discussion, here is a two graph are mentioned. In first, there is a FTR and second one is a XRD. In this FTR confirms the compatibility and XRD confirms a reduced crystallinity of repaglinite in this ionic liquid. In this FTIR shows that the repaglinite and cholic olate forms an ionic liquid without a chemical degradation. The XRD shows that the crystallinity of repaglinite become a more amorphous and ionic liquid form, which help to move a solubility and drug delivery. So in this result, the repaglinite was successfully converted into the ionic liquid, which improve a solubility and the stability. Then moving next, there is a figure 3 and figure 4. In this figure 3, there is a DSC and figure 4, there is a 2D noisy NMR. In this DSC shows that the repaglinite of change from the solid crystallinity form to the stable ionic liquid form. And in second, the 2D noisy NMR confirms that the short interaction between a repaglinite and choline olate. So the two tests are shows that the repaglinite and choline olate interact with the well form of stable ionic liquid. The next one, there is a two table are mentioned in the solubility and optimized by second one is optimized by box Benton design. After that, converting a repaglinite into ionic liquid, it is a solubility increased by more than 100 times. In this, they using a box Benton design. We optimized the patch and found a run 6 gave that highest drug release and the best permeation.
Drug release, counterplot and 3D surface response. Effect of concentration. The concentration of HPMC versus concentration of Utrazit on the drug release showing graph. Figure 6. PVP concentration versus Utrazit concentration on the drug release. And figure 7. HPMC concentration versus PVP concentrations. Flux. Flux are the speed of drug absorbed through the skin. The counterplot of 3D surface response plot illustration that the effect of HPMC concentration versus Utrazit concentration on the flux. Figure 9. Concentration Utrazit versus PUP concentration on the flux. Figure 10. HPMC concentration versus PUP concentration on the flux. Figure 11. This plot of the optimization of the overlay plot. The C1 and C2 is the batch is optimized. The C1 is the selected is the optimized batch. Then the module of evaluation, the C1 is the selected optimized batch showing the table. And then next, evaluation of optimization transdermal batch C1. These are the optimized batch C1. These are the parameters and values. Figure 12 in vitro release. The repaglinide ionic liquid batch 87.202% drug release and not repaglinide ionic liquid. These are batch 37% and figure 13 ex vivo permission oral suspension repaglinide batches and repaglinide ionic batches. They are different percent releasing. And then figure 14 TCA thermal transition analysis repaglinide batch and cholic olate and repaglinide ionic liquid different for degree Celsius and lowest plasticizer effects. And figure 15 plasma concentration repaglinide ionic liquid patch versus repaglinide peak and short duration for the oral suspension. Table 5. In vitro PK parameter. Optimize repaglinide ionic liquid patch C1 versus comparators and parameters and oral parameters are present here. And figure 16. In vitro blood glucose profile 24 hours. Repaglinide ionic liquid patch produced that depends on most sustained hypoglycemic effect overall 24 hours. And figure 17. Glucose tolerance test, that means GTT, show the ionic liquid batch group with the lowest percent glucose changes at each time point, oral and patch groups. And next, conclusion, repaglinide ionic liquid, repaglinide ionic liquids are the successfully prepared using the choline, oleate and the compound. Ionic liquid based a transdermal patch showing in the solubility high drug release and increase the skin permeation, means flux compared to the normal repaglinide patch. In vitro study produce sustained release and better the hypoglycemic effect, no irritation and profile. Thank you.